We're looking at inverse sine of u composed with cosine function. We want to rewrite this as an algebraic expression in terms of u. Since u is a variable, we cannot locate this point on the unit circle. But we can still set up a diagram to represent the angle where the inverse sine of that angle equals u. So inverse sine of u is representing some angle where the sine value equals u. Let's write this u as u over 1 so we can represent sine as the opposite side over the hypotenuse side. In quadrant 1, here's our hypotenuse equals to 1, and the opposite side equals u. This is our angle theta, and we can definitely see that sine of theta equals u over 1, or u. So that satisfies inverse sine of u. It is this angle right here. Next, can we do cosine of this angle? We know that cosine of theta is the adjacent side over the hypotenuse side. We know that the hypotenuse equals 1, but we don't currently have an expression for the adjacent side. So let's set up the Pythagorean theorem. A squared plus u squared equals 1 squared. We'll just call it 1. And now let's solve this for a. A squared, when we subtract u squared from both sides, a squared equals 1 minus u squared. And now a, when we do square root of both sides, equals square root of 1 minus u squared. And we're choosing the positive result because we've assumed that our angle is in quadrant 1, where the cosine value is positive. And now we have this expression for the adjacent side. We can write the ratio of our cosine function. The adjacent side over the hypotenuse. Square root of 1 minus u squared over 1, and the fraction over 1 will leave that denominator out and go with the answer square root of 1 minus u squared.